I'd like to do a quick summary of Becquerel rays. We've seen information about each of these, and so let's kind of put it together in one place. So we're talking about the alpha, beta, and gamma. They have Greek symbols. What are they really? What is their relative mass and their charge? And then how do they act when we put them in an electric field? Now the alpha symbol is a Greek letter A, and I always draw that sort of as a little fish sort of swimming off to the left. The beta is kind of a B with a long tail on the left, and sometimes we'll see that as a B minus, because there's also going to be a positive version of that. And a gamma, I always kind of draw that as a little fish sort of swimming down, and you can see what it sort of really looks like. Now an alpha particle is really just 2 protons and 2 neutrons, okay, which means what that actually is a helium nucleus. Now a beta particle is just an electron, but it's an electron that came out of the nucleus, and it's got a very, very, very high speed, so it's a high-speed electron. Now gamma is just a form of light, and doesn't have a real symbol besides the gamma, and that it's a very, very high energy form of light. But it's light just like other lights, and we were talking about Roy G. Biv, and then above that was the UV, X-rays, and then gamma. So gamma is a very high energy form of light, and the only place it comes from is coming out of a nucleus. Now if we were to take these particles, the Becquerel rays, alpha, beta, and gamma, they would come from some sort of a source. Let's say we had a little radioactive source stuck inside of a lead box. So it's emanating in all directions, but we can direct the beam out because we're absorbing it everywhere else. And as this happens, then we could see that some of these particles are going to come out, and we want to know where are they going to go, the alpha, the beta, and the gamma. So starting off with alpha, we know is very heavy. Since it's 2 protons and 2 neutrons, it's about 7,200 times more massive than the beta, okay, which we'll say that's about 1 times, okay, and then the gamma, okay, basically, since it's light, it has a mass of 0. So go back here to the alpha particle. Since it's 2 protons and 2 neutrons, then it's going to have a positive charge. So a positively charged particle coming out, if it comes into a contact with something that's got a positive and a negative, then we can imagine it would be attracted to the negative and repelled by the positive, so we'd expect the alpha particle to go downwards. But the other thing too is, since it's so heavy, it's not going to go downwards very much. It's pretty difficult to get that to bend. Now if we switch over to betas, okay, beta, since it's an electron, it's going to have a negative charge, so it would be attracted to the positive side, but because it is so small, so lightweight compared to the alphas, it's going to be bent quite a bit. So we say the beta particles would be here, alpha particles would end up down, so downwards a little, bent up a lot, and then the gamma, because it's just light, is going to go straight through, unbent by either one of those. So neither up nor down. And that's what you should know.